Final loose end to tie up with fractions is these kind of fractions. These weird looking fractions where the number on the top is bigger than the number on the bottom. And actually they are not really as complicated as they seem. Think about the 5 over 2 first of all then. So that's 5 halves if we read that slightly differently. Well, let's draw 5 halves. There are 5 halves. I've chosen a circle because it's nice and easy to illustrate what's going on. There are 5 halves. Now there is a different way that we could arrange those. And we could choose to say group the halves together where possible to make wholes. How many halves do we need to make a whole? 2. So let's combine 2 and then 4 and then have 1 left on its own. So that's 2 wholes and 1 half left over. It's still the 5 halves, but they're just grouped differently. So what we've now got is we've now got 1, 2 and a half left over, which we could write as 2 and a half. The whole number part first and then the fraction part second. And it turns out that these two things are the same. So when we talk about 5 halves, what we've actually got is we've got 2 wholes and 1 half left over. Now with any of these kind of fractions where the number on the top is bigger than the number on the bottom, this is what we've got. It just means we've got more than 1. It means we've got more than a whole or more than a certain number of wholes. And these are two ways of writing the same information. Where the number on the top being bigger than the number on the bottom in that fraction form is called an improper fraction, and where the mix of whole numbers and fractions is called a mixed number. And what you might need to do is you might need to switch between improper fraction and mixed number form. Either go from improper fraction to mixed number, or from mixed number to improper fraction. And all it really is a bit of counting. If, for example, we had 11 over 3, say, as an improper fraction. 11 thirds. Well, there they are. 11 thirds. And we can group those thirds in a particular way. We can group 3 of them together to make a whole. So we could group 3 to make 1 whole, and then 4, 5, 6 to make a second one, and then 7, 8, 9 to make a third one. So that's 3, 6, 9, and that's as close as we can get. So that's 3 wholes. And then we've only got to 9. We've got 11 overall. That's 2 left over. So we will have 2, 3 plus 2 thirds left over is 3 and 2 thirds. Notice that the type of fraction is the same in both forms. With the previous one, we were dealing with halves and halves. Here we're dealing with thirds and thirds. The type of fraction is not going to change, which makes sense because you're just grouping them differently.
So a question could say, convert the improper fractions to mixed numbers. 81 over 8, for example. Well, we know that the type of fraction is going to stay the same. So we know it's going to be some number of wholes and then a certain number of eighths overall. So we're counting in eighths, because 8 eighths make a whole. So we've got 8, 16, 24, 32, 40, 48, 56, 64, 72, 80. Now that's as close as we can get without having more eighths than we've got. 80 is as close that we can get. Now that was 10 eighths, so clearly we've got 10 of them. But 10 eighths was 80, and we've got 81, so we must have 1 eighth left over, so 10 and 1 eighth. Second example, 37 over 7. So we're dealing in sevenths this time, which means 7 of them will group together to make a whole. So we're going to go 7, 14, 21, 28, 35, and that's as close as we can get to 37 without going over. So that's 5 wholes. But 5 was 35, and we've got 37, which means we've got an extra 2 sevenths remaining. And again, the type of fraction is the same in both cases.
We could go the other way too. We could start with a mixed number like 4 and 3/5, and we can count in exactly the same way. 4 and 3/5 then. So we know that our answer is going to be something to do with fifth. It's going to be a certain number of fifths. Well, think about the 4. Each one of those wholes is made up of a certain number of fifths. So we've got 5 in the first, and 5 in the second, so that's 10, and then 5 in the third, so that's 15, and then 5 in the fourth, so that's 20. So 5, 10, 15, 20 for the 4 wholes, plus 3 extra ones for the 4 and 3 fifths. That's 5, 10, 15, 20, 21, 22, 23 fifths.
Convert the following mixed numbers into improper fractions. So in each case, we're going to be taking this mixed number, this whole number and the fraction part, and we're going to be switching them for a single improper fraction. The type of fraction won't change. So in this first one, 3 and 4 ninths, we're going to still be working in ninths. Now we're working in ninths, which means 9 ninths make up a whole. So in each of these wholes, there are 9 ninths. So there are 9 in the first one, 18 across the first two, and 27 in all three. 9, 18, 27, plus the 4 left over, so that's 27, 28, 29, 30, 31 ninths. And in the second example, 7 and 2/3, well, we're dealing in thirds. The type of fraction isn't going to change. We're dealing in thirds, so 3 of them go together to make up a whole. That means there are 3 in each of these, so we have got 3, 6, 9, 12, 15, 18, 21, in all 7, 21 plus the extra 2 gives us 23 thirds. Final thing you might be asked to do with mixed numbers is you might be asked to do add, take, times or divide with them. The advice is going to be the same for each of those, add, take, times and divide. Where step 1 is going to be rewrite any mixed numbers as improper fractions. That's all of them in the question, so that you are only dealing with fractions. And step 2 is to do the add, the take, the times or the divide as you would for any other type of those questions with fractions. So that's adding and taking, make them the same type, and then either add or take the top numbers. For the timesing, times the 2 top numbers together, times the 2 bottom numbers together. And for the dividing, going through that process of keeping the first one as it is, swapping the second one upside down for the reciprocal, and swapping the divide for a times. Just to make this point, for example, 3 and 2/5 times 2 and a 7th. Well, this first step is going to be to switch each of those mixed numbers for improper fractions. So 3 and 2/5 we are going to switch first of all. Well, we're dealing in fifths, so our improper fraction is going to be working with fifths. 5 fifths make a whole, so that's 5, 10, 15 in the 3 wholes, 16, 17 there altogether, so 17 fifths. And the other one, the 2 and 1/7, we're dealing in sevenths, so we're going to have a 7 on the bottom. 7 sevenths make a whole, so that's 7, 14 across the 2, plus 1 is 15. The question here wants us to times. Once we're at this point, we do the add, the take, the times or the divide as we normally would for these questions. This one happens to be a times, so we're going to treat this as a times. For a times question, remember, we're going to times the 2 top numbers together, and we're going to times the 2 bottom numbers together, and that'll give us top and bottom of the answer. So on the top, we're going to do 17 times 15. We might nip off to the side, for example, and work that out, but 17 times 15 would come to 255. Again, you'd probably need to do some working out for that. It's not something you'd be expected to know. And on the bottom, 5 times 7 is 35. That looks a bit weird, but we should probably cancel our answer down to the simplest form, as we always do. Well, they both end in 5, so they will both divide by 5, top and bottom. 255 divided by 5, not the easiest thing to do, but 25 divided by 5 is 5. So 250 divided by 5 is 50. We've got 255, so it'll be 51 on the top. 5 lots of 51 to get 255. 51 over 7 on the bottom. 35 divided by 5 is 7. That is it. 7 is a prime number, so the only thing that will divide on the bottom is 7, and 51 won't divide by 7, so that is the simplest form. And that might be acceptable as an answer. Alternatively, it might not, and it kind of depends what the question says. The question might just say work out, in which case then you are welcome to leave the answer in whichever form you wish. It might say work out, giving your answer as an improper fraction in the simplest form, in which case that is perfectly acceptable as an answer, and in fact more than acceptable, correct. Or the question might say, and give your answer as a mixed number. So it is possible that we will have to do one final step and convert that improper fraction back to a mixed number. Well, if we did have to do that, we'd be dealing in sevens, so it would be some number of wholes plus a certain number of sevenths? Well, 7, 14, 21, 28, 35, 42, 49. That's as close as we're going to get. So 7, 49, 50, 51. So 2 sevenths remaining. And 7 and 2 sevenths would then be the answer to that. But again, sometimes it might be acceptable to leave it as this. Key thing though, whether these questions are add, take, times or divide. This one happened to be a times, but I could have done an example with any of the three. Whether these questions are add, take, times or divide, step 1 is always going to be switch them to be improper fractions, because you know how to do add, take, times, divide with fractions, whether they are proper or improper. And then our second step is going to be to treat this question as you would for any other. In this case, we did it as a standard times. You might then have to switch your answer back at the end. It depends what the question says.